Hey everyone, welcome back. So today in my video I'm gonna teach about capacitance in series and in parallel. Like what are the different formulas when we connect capacitance in series and capacitance in parallel. Okay. First thing that basics which are required is the first main formula, that is Q is equals to CV. Q is equals to CV, where Q stands for charge, or indirectly I can even say current. C stands for capacitance. Okay. V stands for voltage. Capacitance is nothing but a device which stores the energy. Okay, and we represent capacitance like this, like this, two parallel plates kind of thing. Okay, here I'm writing. This is how we represent capacitance, and this is how we represent resistance. This is capacitance, this is resistance, this is capacitance. Okay, the case, okay, we'll discuss it later. This is one basic formula which I will be using. Q is equals to CV. Okay, now two circuit diagrams, that is first capacitance in series. Series means nothing but they are in line, they are in line. Okay, this is capacitance in series, CCC. The capacitance values I'm taking it as CCC. And then coming to parallel, which means they are parallel to each other, like this. This is one capacitor, this is one capacitor, this is one capacitor, and then these are connected like this to a battery. Okay, now, and even let me say these are having capacitance of CCC. Okay, it is given that the capacitance is identical, which means capacities are same. Okay, now if you remember in resistance, okay, we are just recapitulating or something. Resistance, we had RS is R1 plus R2 plus R3, and RP, 1 by RP is 1 by R1 plus 1 by R2 plus 1 by R3. Correct? This we had in case of resistance. Now let us see what we will get in case of capacitance. Will we get same capacitance in series is C1, C2, C3, or what else we will get? Let us check now. Okay, say putting on here also the same rule applies here, that is in series what remains constant? Q remains constant, or I can say I remains constant, current remains constant. And in parallel, voltage remains constant. Same basics even apply for capacitance as well. Okay, now putting down the basic formula, that is Q is equals to CV. Correct? Now this is in series, so in series can I say Q remains constant? Q is remaining constant. Now can I say CV is equals to constant, and can I say V is equals to 1 by C? Right or not? V is equals to 1 by C, because CV constant, I am sending C this side, neglecting constant, so we are getting V is equals to 1 by C. So V is inversely proportional to C. Total voltage in this is V1 plus V2 plus V3. So can I say total capacitance, or capacitance in series? What is capacitance in series? Or better say, for better understanding, can I write VT, total voltage, as 1 by total capacitance? How? Voltage is nothing but 1 by C. One voltage, total voltage is nothing but 1 by total capacitance, or I can say 1 by total capacitance in series, which is nothing but V1. In place of V1 I can write 1 by C1, 1 by C2, 1 by C3. Correct? Because they have given that all the capacitance are equal, can I say 1 by CS is 1 by C plus 1 by C plus 1 by C, which is nothing but 3 by C. Correct? This is 1 by C in series. So C in series is nothing but C by 3. Okay, this is the formula that we are given when we have the capacitance in series that is identical. If they are non-identical, then this is the basic formula that one should use. Okay, main thing here is you have to know these two rules. In series, Q remains constant. In parallel, V remains constant. And then how to apply it? Q is equals to CV. Q remains constant, so C is inversely proportional to V. And here, same way, Q is equals to CV, correct? So in parallel, voltage is constant, so voltage remains constant. So can I say Q is proportional to C? Q is proportional to C. So in the place of QT, I can write Q1 plus Q2 plus Q3. Q is nothing but current here, okay? Then can I say in the place of QT I can write CT, because Q and C are directly proportional. So I can say total capacitance or capacitance in parallel also, which is nothing but C1 plus C2 plus C3, or I can say capacitance in parallel according to our given condition C plus C plus C, which is nothing but 3C. According to given condition, that is identical capacitance, we have got 3C, otherwise this is the basic formula. Okay, this is there and this is here. Now here, same way, Q is equals to CV, V remains constant, so Q is proportional to C. So you have to basically understand, in series current remains constant, in parallel V remains constant. Okay, now let us compare the same thing with resistance. Capacitance in series is 1 by C1, 1 by C2, 1 by C3, whereas resistance in series is R1, R2, R3. So this basic difference you have to understand, and to avoid confusion between resistance and capacitance, we can derive on this spot, by using this Q is equals to CV, or if our resistance V is equals to IR. So okay, I hope you have understood the derivation. There's very small derivation to know the capacitance, what is the formula for in series and in parallel. Okay, and even I have explained the derivation for resistance in series and parallel. If you want, the link for this explanation will be provided in the comment section below. I hope you all understood and enjoyed this class. Thank you so much.